Imagine you're holding a coin. You flip it into the air. While it is spinning, it is a blur. It is not heads. It is not tails. It is a mixture of both. But the moment it hits your hand and you look at it, it becomes one thing, heads or tails. That makes sense, right? That is how the world works. Things are uncertain until they settle down. But what if I told you that the coin doesn't settle down because it hits your hand? What if I told you that the coin settles down only because you looked at it? And what if I told you that if you didn't look at it, the coin would remain a blur forever? And what if I told you that if you looked at it fast enough, if you stared at it with enough intensity, you could freeze the coin in midair and prevent it from ever landing? Welcome to the world of quantum paradoxes. We grow up believing in a logical universe. We believe that a causes B. We believe that things are either true or false. We believe that the past is set in stone and the future is unwritten. But down in the basement of reality, in the subatomic world that makes up your body and your brain, none of those rules apply. Down there, a cat can be alive and dead at the same time. Down there, watching a pot of water can literally stop it from boiling. Down there, what you do tomorrow can change what happened yesterday. It is a world of madness. It is a world of contradictions. But it is also the real world. It is the foundation of everything you see and touch. If you are brave enough to let go of your common sense, if you are ready to unravel the knots of reality and see the impossible truth underneath, please hit that subscribe button right now, because we are about to break the laws of logic and I want you to be there when the pieces fall. To understand quantum physics, we have to stop trying to solve the problems and start appreciating the paradoxes. A paradox is not an error. A paradox is a signpost. It is a sign that tells us we have reached the edge of our understanding. Let's start with the grandfather of all paradoxes, the one you think you know, but you probably don't. Paradox number 1, the zombie cat. You know the setup. Erwin Schrödinger, a brilliant physicist, wanted to show how ridiculous quantum mechanics was. He wasn't trying to explain it, he was trying to mock it. He said, imagine a cat in a sealed steel box. Inside the box there is a hell machine, a tiny bit of radioactive substance, a Geiger counter, a hammer, and a flask of poison. If the radioactive atom decays, the counter detects it, the hammer drops, the poison is released, and the cat dies. If the atom does not decay, nothing happens and the cat lives. Now, according to quantum mechanics, until you measure an atom, it is in a superposition. It has decayed and not decayed. Therefore, Schrödinger said, the cat must be entangled with the atom. The cat is alive and dead. He thought this was absurd. A cat is a biological organism. It cannot be a ghost. But experiments have proven him wrong. Not with cats, but with molecules, with buckyballs, even with tiny drums visible to the naked eye. We have put them in superposition. They are vibrating and not vibrating at the same time. But here is the real paradox, the part that keeps scientists up at night. It is called the collapse. When you open the box, the superposition ends. The universe chooses a timeline. The cat is alive or dead. But who collapses the wave? Is it you, the human? What if a video camera records the inside of the box? Does the camera collapse the wave? If the camera records it but no human ever watches the tape, is the cat still in superposition? This implies that consciousness might be the key ingredient in reality. It implies that the universe requires a conscious observer to define what is real. But this leads us directly into the second, much scarier paradox. A paradox that makes you question if your friends are even real. Paradox number 2, Wigner's friend. Eugene Wigner was another Nobel Prize winner. He took Schrödinger's cat and he made it a nightmare. He said, okay, let's imagine I have a friend. Let's call him Bob. Bob is in a closed laboratory. Inside that lab, he performs the Schrödinger's cat experiment. Bob opens the box, he looks, he sees a live cat. The wave function collapses for Bob. He is happy. He writes down the cat is alive in his notebook. But I am Eugene Wigner, and I am standing outside the laboratory. The door is closed. I cannot see Bob. I cannot see the cat. According to quantum mechanics, until I interact with the system remains in superposition. So to me, standing in the hallway, the entire laboratory is the box. Bob is in a superposition. Bob has opened the box and Bob has not opened the box. Bob is seeing a live cat and Bob is seeing a dead cat. Bob is happy and Bob is sad. From my perspective, Bob is a ghost. But from Bob's perspective, he is real. He has made a measurement. He knows the truth. So who is right? Is the cat definitely alive, Bob's reality, or is the cat indefinite, my reality? Can two realities exist at the same time? This isn't just a thought experiment. We have done this in the lab using photons. We created a Wigner's friend scenario. And the results are terrifying. The results suggest that there is no such thing as objective reality. Facts are relative. What is true for Bob is not true for me. The cat is alive for him, but undefined for me. We used to think the universe was a single stage where we all acted out our lives together. We thought we all saw the same play. Wigner's friend suggests that we are each living in our own private bubble of reality. We are each collapsing our own wave functions. It suggests that I can never truly know your reality and you can never truly know mine. We are trapped in our own observations. It unravels the very idea of a shared universe. It suggests that truth is not a noun, it is a relationship. Now let's move to a paradox that gives you a superpower that sounds like magic but is actually strict physics. Paradox number 3, the quantum Zeno effect. You have heard the saying, a watched pot never boils. It is an old wives' tale. It means if you are impatient, time feels slow. But in quantum mechanics, it is literal. If you watch the pot intensely enough, it will physically never boil. Let me explain. We know that quantum systems change over time. An unstable uranium atom will eventually decay and shoot off a particle. It transitions from state A unbroken to state B broken. This transition takes time. It is a wave flowing from A to B. But remember the observer effect. When you look at a system, you force it to choose a state. You collapse the wave. So imagine the atom is trying to decay. It starts to slide towards state B. But then you check on it, you measure it. The measurement asks, are you decayed yet? Since it has only just started, the answer is mostly likely no. So the wave snaps back to state A, it resets. A millisecond later, it tries again. It starts to slide towards state B. You check on it again, are you decayed? Snap, it resets to state A. If you measure the atom fast enough, if you check it 1,000,000 times a second, you can freeze it in state A forever. You can stop time for that atom. This is the quantum Zeno effect. It is named after the Greek philosopher Zeno, who argued that motion is impossible. We have proven this in the lab. We have taken atoms that should decay in a fraction of a second, and by hitting them with rapid pulses of light, which counts as measuring them, we have kept them alive for 30 times longer than they should exist. We stopped the clock of the universe just by looking at it. Now think about what this means for the paradox of change. It implies that observation is a form of control. It implies that the more we scrutinize a situation, the more we freeze it in place. Have you ever tried to change a bad habit, and you focus on it so hard, you obsess over it every second, and yet you feel stuck, you feel like you can't move? Maybe you are xenoing yourself. Maybe your constant observation of the problem is collapsing the wave function back into the problem state over and over again. To allow change, to allow the atom to decay, to allow the transformation to happen, you have to look away, you have to let the system evolve in the dark, you have to allow the sewer position. This paradox unravels our need for control. It tells us that sometimes the only way to get from A to B is to close your eyes and trust the wave. And finally, we come to the paradox that breaks the timeline, the one that destroys the idea of destiny. Paradox number 4, retrocausality and the delayed choice. We are taught that the past creates the present, and the present creates the future. Time is an arrow, it flies in one direction. But quantum mechanics says, maybe not. There is an experiment called the delayed choice quantum eraser. It is complex, so I will give you the simplified version. Imagine you are firing photons at a screen through 2 slits, the double-slit experiment. If you don't look, they act like waves interference pattern. If you look, they act like particles, 2 bands. Now imagine we set up the experiment so that the decision to look or not look happens after the photon has already hit the screen. We send the photon through the slits, it hits the screen, it makes a mark. Then, a billionth of a second later, we decide whether to destroy the information about which path it took or keep it. Common sense says it shouldn't matter. The photon has already hit the screen, the event is over, the past is written. But the experiment shows something impossible. If we decide to erase the information in the asterisk future asterisk, the photon in the asterisk past asterisk creates a wave pattern. If we decide to keep the information in the asterisk future asterisk, the photon in the asterisk past asterisk creates a particle pattern. The photon seems to know what we are going to do before we do it. Or more accurately, our choice in the present is reaching back in time and rewriting the history of the photon. This is retrocausality, the future causing the past. This paradox unravels the entire narrative of your life. It suggests that your history is not a fixed videotape sitting on a shelf. It suggests that your history is fluid. It suggests that the decisions you make today are vibrating backwards down the timeline, influencing the events that led you here. It sounds insane, but John Wheeler, one of the greatest physicists of the 20th century, believed that the entire universe might work this way. He called it the participatory universe. He suggested that by observing the stars tonight, stars that shone billions of years ago, we might be playing a role in creating the Big Bang itself. Our observation now might be necessary for the universe to have begun then asterisk. We are not just the children of the universe, we might be its parents. So how do we unravel these paradoxes? How do we live with them without going crazy? We don't solve them, we embrace them. We realize that the paradox is only a problem because we are trying to force the universe into a tiny box called human logic. We want things to be black or white, alive or dead, here or there, past or future. But the universe is not binary. The universe is a spectrum. Unraveling the paradox means accepting that you are a quantum being. You are Schrödinger's cat. You are full of infinite potential, dead and alive, successful and failing until you decide to observe yourself. You are Wigner's friend. You are living in your own unique reality, a truth that belongs only to you, and that is okay. You don't need everyone to agree on your reality for it to be real. You are the Zeno effect. You have the power to freeze moments with your attention or let them flow by looking away. You control the speed of your own life by how tightly you hold on to it. And you are the time traveler. Your choices today matter not just for tomorrow, but for yesterday. You can heal your past by changing your perspective in the present. Quantum mechanics tells us that we are powerful. It tells us that we are not just cogs in a machine. We are the operators of the machine. We are the observers. We are the creators. We are the ones who collapse the wave. The world is weird. It is spooky. It makes no sense. And isn't that wonderful? It means that nothing is set in stone. It means that the story is not over. It means that anything, literally anything, is possible until you open the box. So look at your life. Look at the coin spinning in the air. It hasn't landed yet. It is a blur of possibility. And you are the one who gets to decide how it lands. If this journey into the madness of quantum paradoxes expanded your mind, if it made you question reality in the best possible way, please hit that like button. It helps us collapse the wave function and reach more potential observers. And if you want to keep exploring the mysteries of the cosmos, from the center of a black hole to the edge of consciousness, hit subscribe. We are going to keep unraveling the universe, one paradox at a time. Let me know in the comments which paradox keeps you up at night. Is it the zombie cat or the idea that you might be creating the past? I'll see you in the next supposition. Stay curious.